So, we have here a window is in the shape of a rectangle combined with a semicircle as shown. The rectangular part of the window is 50 centimeters long and 90 centimeters high. Find the area of the window in centimeters squared. How do you find the area of the black part here, Charlie?
70
Yeah.
by 90.
70 by 90 gets you?
6,300.
6,300 centimeters squared. Barry, how do you get the green part? The semicircle? There's a formula for that, guys. What's the formula?
Is it 35 or 35?
First of all, the radius is 35. How do you know the radius is 35?
Because you have
Half of 70. What's the formula for this, guys? There's a formula.
Hold on.
360.
Is it area or perimeter we're looking at here? What's the area formula?
It's
Pi
Pi r squared, yeah, got it. Now,
So it's 180.
100. Why is it 180? Where's that coming from?
half of 360.
It's 180 degrees, a semicircle. What's the pi value?
22/7.
And what's the radius value?
35 squared.
And when you put all of that into the calculator, 1,925 centimeters squared. What you need to do with both answers?
Plus them.
Why'd you plus them?
To get actual width.
Because you want to add them together because they're two parts of the same object.
8,225 centimeters squared.
Okay, how many people got that one out? One person in the entire class got it out. Now, lads, the diameter of a €1 coin is 23.25 millimeters. Calculate the circumference of the coin. What is the formula for circumference on that page? Circumference is the outside of the coin.
2 pi r.
Oh, yes.
L equals
2 pi r.
2 pi r. What's pi in this question?
3.1.
And what's the radius?
11.625.
Now, it gives us the diameter, not the radius, so we have to divide the diameter in by 2. So that's 23 point, yeah, what's
11.65.
okay, 11.625, that one there. Multiply that by 2 and 3.14, right? And what you get?
73.005.
73.005. Centimeters, millimeters. Just millimeters, isn't it? Why is it not millimeters squared, lads? Why is it not millimeters squared? Sorry? Yeah. Area is a shaded in region. These are always in meters squared, centimeters squared, millimeters squared. However, lengths aren't. Do you see the way the circumference is basically a length on the outside? Do you see that? It's a length on the outside, so therefore it's not. Therefore, it doesn't work that way. Okay. So, what we're going to do next, guys, is find the distance travelled in 5 complete revolutions. How would you do that? Multiply by 5, and you get
365.025.
365.025. Millimeters or centimeters? Millimeters. Why is it millimeters? Okay. Do you have a question?
It's not really a question. I got that wrong because I wrote down 365.25 instead of the 0 for
Okay, I got you. Just made it just a decimal error, really. Okay. Find the number of complete revolutions it makes if it rolls 50 centimeters. What's the problem with that question? It speaks in Japanese, we speak English. It speaks centimeters, we speak millimeters. We need a translator. How do you translate centimetres into millimetres? Multiply by 10.
Oh, yeah.
Do you ever see your ruler and 1 centimetre has 10 tiny lines in between 0 and 1 centimetres? They're millimetres, so you multiply by 10. So 500 millimetres, okay, is our distance. We have to divide that by the amount of distance in one of our wheel turns or coin turns. So divide that one by that, and what do we get? $6.85. Now, the number of complete revolutions is 6.85. That's 6 complete revolutions and very close to being 7 complete revolutions, right? But is it 7 complete revolutions? So the answer is 6. Because you either complete 6, you either complete 7, or you don't. The answer is we don't. That could be 6.99999. The bottom line is, did you get over 7? No. So your answer is still 6 revolutions. You know what a revolution is? Every time it turns around. That's 1 revolution. It's 2 revolutions. See the 1, 2. That's a revolution. Okay? Now, question 8. Athletics track. Now, how do you get the length of a semicircular end? Barry, what formula on your page in your notes will do that for you? The length, not the area, the length. Any ideas? What page are you on for that, Pat?
Page 9.
Page 9.
It's L equals 2 pi r multiplied by theta over 360.
Okay.
And
It's the length of the blue region. Blue region is what angle is in it? What angle is here? 180 because it's a half a circle. And then what's 2? What's pi in this question?
22.
Now we have to find the radius. That's the part 1. What's the radius of the semicircular ends? The diameter is 98, which makes the radius 98 divided by 2? 49. L therefore equals, put all that into the calculator. That's going to be a pretty long calculation. Do you have your calculator, Charlie?
$154.
154. Is that right? 154 centimetres? Okay. So, 154 centimetres is the blue end. Is everybody happy with that? How many blue ends do we have?
2.
Here's the other blue end. So what's that make it? Oh, sorry, it's meters, not centimetres, by the way.
380.
That's another 154, isn't it? And this is 146. We need to add all the sides together. You have to add all the different parts together to find out how big is one lap. Start from here and go this way. So what do we encounter first? 154 circular ends. After that we go on to the 146 straight. Then we go on to the 154 semicircular end. And then our final straight is 146. Makes a grand total of a 600 metre track. 600 metres. Calculate the number of laps an athlete would complete in a 5.4 kilometre race. Will it be more than 1 lap or less than 1 lap? You want to do 5.4 kilometers.
More.
It's going to be more, isn't it?
Yes.
Now, problem is, they're speaking kilometers, we speak meters. How do you change kilometers into meters? Nope.
No, you
Because you
divide
wrote
it
down,
by right.
there you just converted down, so.
Multiply by 1,000. Kilometers, kilo, means there's 1,000 meters in 1 kilometer. So it's 5,400. 5,400 is the distance we want. How many 600s will divide into that? What do we get? 5,400 divided by 600? 9 laps. Anybody get 9 laps?
Yes.
Did you?
No.
Now, an athlete ran 4 laps in 10 minutes. Calculate his speed in kilometers per hour. I might just have to do this. I know. Now, there's a triangle called DST, Dad City Triangle. Cover up the one you're looking for. You're looking for speed. Cover up speed. What are you left with? Distance divided by time. Now, it wants it in kilometers per hour. Okay? So if you ran 4 laps, how far did you run? You ran 600 multiplied by 4, which is 2,400 meters. How do you turn meters into kilometers?
You divide by 1,000. No, you divide it by.
Divide by 1,000 this time. 2.4 kilometers. You happy with that? Now, how many we want it in hours, but what fraction of an hour is 10 minutes? 1/6, or 10 out of 60. So you get your thing, you go 2.4 divided by 10 out of 60, and you get 14.4. He averaged running 14.4 kilometers an hour, which is actually quite fast. Okay.